Assalamualaikum warahmatullahi wabarakatuh and hi. We are group 1 from K2. We would like to present about ocean food web dynamic. Antarctic marine ecosystem have been dominated by the food chain from phytoplankton through Antarctic krill to the great beluga whales. This has been seen as an efficient pathway for transferring energy from primary producer to the higher trophic level. Other than that, the archetypal creep pathway, other alternative pathway of energy transfer exists. This pathway benefit other predators they are less dependent on krill such as toothfish, toothed whale, seal, penguin, and flying birds. The diversity of energy pathway and their interaction with one another is typical of consumer network in food web. This suggested that the external force of change in certain taxa may result in a cascade of indirect interaction across the food web, which make the consequence of the change unpredictable. Modeling is an essential approach to answering such questions regarding the ecosystem response to changes and effect on ecosystem services. One of the modeling is qualitative network modeling with QPress. Qualitative network modeling with QPress is a qualitative network model that is constructed where the interaction between components are simplified to either positive or negative effect. It is useful for capturing feedback effect in qualitative prediction and for formulating. It also used to test fundamental understanding of system structure and respond to perturbation, making it very well suited to the application. The several simulations that carry out are first an increase in cell, which is gelatinous zooplankton. It may enhance most ecosystem services, including the krill and toothfish fishery, conservation of beluga whales, and carbon export, and with uncertain, which is not clearly negative or positive. Second, an increase in beluga whales. In the absence of any other change, on any other change, would have negative implications for krill and all predators, including both those that mainly feed on krill and those that mainly feed on fishes and squid. Third is uncontrolled fisheries, both for krills and toadfish, would have negative implications for both the target species and carbon export.
And hi, I would like to talk about the microbiome. Microbiome is occur between living organisms that live in the ocean. The word of microbiome is referring to the living organism which is marine bacteria like phytoplankton, zooplankton, and nectar. While the word of looping is referring to the cycle when marine bacteria start to enter the food chain by eating other organism or become decomposer of other organism or they become prey for other organism which is higher trophic level than them. Okay, that's all.
So, I will be explaining the connection of the microbiome loop with the Antarctic food web. Before we go further ahead, let us recap on what Ida just talked about the microbiome loop. Basically, the microbiome loop is a trophic pathway by marine bacteria where dissolved organic carbon, which is also known as DOC for short, reaches the higher trophic level. In other words, the microbiome loop consists of a complete microecosystem that produces, utilizes, and circulates dissolved organic carbon in the ocean. The microbiome loop plays a big role in the Antarctic food web as all marine organisms require DOC. But there's only a small portion of DOC that is utilizable by the marine organisms. Therefore, marine bacteria introduces DOC into the Antarctic food web. They introduce the DOC via a few methods. Firstly would be by decomposing the organic materials put into the water when zooplankton eats phytoplankton. Secondly, it would be by breaking down organic matter into dissolved form so the marine bacteria can utilize it themselves. And thirdly, by converting the organic materials released by zooplanktons into inorganic form. Therefore, the microbiome is considered as a carbon sink due to the involvement of several trophic levels and large fraction of organic carbon along the process. The main effect of the microbiome is to accelerate mineralization and regeneration of production in the nutrient-limited system. Marine biologists believe that the microbiome contributes the greatest fraction of organic particles in the water column. And also, the productivity of the microbiome is thought to be much larger than the higher trophic level. Therefore, the microbiome plays a major role in the Antarctic food web as it regulates the DOC in the ocean, thus directly affects the higher trophic level food web. Thank you.
Now, I will explain the external forces that can cause changes in ocean food change. The first one is climate change. Climate change is rapidly warming the earth. In the ocean, most heat from climate warming stay on the surface and it will take centuries to work down into the deeper water. As this happens, it will change the ocean circulation pattern and make ocean food chain less productive. For example, climate change could alter the key factors that drive marine ecosystem, including the winds and ocean circulation. This disruption will transfer nutrients from surface water down into the deep ocean and leaving less nutrients at the surface to support the plankton growth. Under normal conditions, winds and current will cause mixing that eventually brings nutrients back up to the sunlight surface water. If this did not happen, the phytoplankton eventually would completely run out of nutrients, which would affect the entire ocean food chain. The second external force is krill overfishing. Krill is rich in oil brimming in omega-3 fatty acids that some companies sell in pills. Krills are also harvested with special enzymes that can be used to clean wounds and even to clean contact lenses. Before this, the difficulties in processing krill on ships and high fuel price kept the annual catches remain low. But economic equation is changing fast because of the rising food price, falling global fish stock and better ship-based technology. Within 5 years, the annual krill catch could reach more than 100,000 tons to several million tons per year. The third is ice melting. The sea ice helps to determine when and where the food becomes available to creatures living in the ocean or on the seafloor. The meltwater is less dense and less salty than the surrounding water. As a result, the water forms layers and the fresh water, which is full of nutrients, will stay on top. This meltwater helps to rise algae bloom. These blooms, in turn, feed the copepods and other small floating sea creatures. But on the other hand, the melting of the sea can cause dramatic impact to the some bird creatures such as eiders, a kind of sea ducks, to search for food. This bird used the sea as a stable launch pad to dove in the water to search for mollusks. For the bird, sitting on the ice and feed on the underlying prey is easier than to swim. Next, researcher has measured that there is an increase in small copepods, but decrease in fattier and more nourishing large copepods. And this is a bad news for new young fish that need larger copepods to survive through winters. These scenarios can put some of the creatures at risk of extinction. That's all for me.
Here are 5 scenarios of change and implication for ecosystem that had been made to see the effect on krill target species, fish target species, conservation of krill species like adult penguin and peck icy, conservation of fish or squid species like emperor penguins and certain elephant seal, And the fifth one, conservation of balance well, whether the effect is positive or negative effect. So the first scenario is decline in large phytoplankton. It means decrease number of large phytoplankton and increase in number of small phytoplankton. So the first result is it will give negative effect to krill target species and conservation of krill specialists. This is because krill target species eat the large phytoplankton. Second, increase in fish target species and carbon export potential. Here, because the fish target species eat the small phytoplankton which is high in number. The conservation of fish specialists and balloon whale are ambiguous, means the result is unclear. The range is between 40 to 60%. Second scenario is increasing gelatinous zooplankton. The gelatinous zooplankton here means salt. So the first result is increase in krill and fish target species. Second, increased conservation of baleen whale and carbon export potential. Third, ambiguous result in conservation of krill and fish species. The third scenario is increase in baleen whale recovery. The first result is it will give negative impact on the krill and fish target species, also in conservation of krill and fish species. Here we can see that the balloon the balloon whale has shown the top-down forcing, means if species at the top of the food web are directly affected by external force, then consumer pressure from the top down through the food web can cause shift relative abundance of the lower trophic level species like krill target species, the fish target species, conservation of krill and fish species. Second, increase the conservation of baleen whale. Third, ambiguous result in carbon export potential. The fourth scenario is uncontrolled krill fisheries. So, the first result is it will give negative effect on krill target species, conservation of krill specialists, and baleen whale, also the carbon export potential. This is because the the krill specialists and baleen whale are eating the krill target species. So that's why they will affect too. Second, ambiguous result on fish target species. Third, increase in conservation of fish species. The fifth scenario is uncontrolled fish fishery. So it will give negative effect on krill and the fish target species, also carbon export potential. Second, increase in conservation of krill and fish species because the fish are not on their diets. And third, ambiguous result in conservation of baleen whale. That's all the scenario that have been made and the effects on the fifth animals. Thank you.
Okay, so we have shown that the Southern Ocean food web structure and change have important policy application. We can indicate that uncontrolled fishing, whether for krill or for toothfish, will impact the ecosystem service, including the climate mitigation through the carbon export. We use the simple modeling approach to show the impact of the single force of the change, which is our five scenario that is shown in our poster are more complex for Southern Ocean ecosystem that commonly believe because of multiple interacting energy pathways and the feedback among them. If a species eats predominantly krill, that will be a krill predator relying on the krill energy pathway. If it eats fish, then it will be a fish predator in the fish energy pathway. If a species eats mostly krill but switches to fish when krill are in short supply, then it will be a predator, eats krill and fish, and so on. From the poster, we also can see the microbial loops. Okay, the microbial loop is a loop that happens between the organism in the ocean. But in this case, the pathway is involved the marine bacteria where dissolved organic carbon, the DOC, such as the plankton. Microbial loop describe that the plankton food chains are more complex and that microbes play a much greater role in them. The microbial loops has been returned to the microbial food web. It is because all marine organisms such as krill, toothfish need the DOC that form the microbial loop. So the protozoa introduce DOC, which is the dissolved organic carbon, by entering the food web. So we can conclude that there is an interaction between the microbial loop and the food web. Thus, it's important change in the marine ocean. Okay, it's that for me. Thank you.